Welcome back to the Greater Essex County District School Board calendar, where we are exploring the fundamentals of mathematics. Each month, we're diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide, and in particular, the tables summarizing the curriculum expectations from our current Ontario mathematics curriculum that always has and always will continue to be fundamental for developing students' understanding and proficiency in mathematics. Over the next two videos, we'll continue discussing how we can develop mental math skills in order to work towards mastering math facts. In this video, we'll take what we've learned about addition and apply it to multiplicative scenarios. As usual, let's start with a contextual scenario. This time with my favorite, donuts. That's right. Inside a typical donut box, we have a dozen donuts, but let's go ahead and reveal them for us here. We have 12 donuts. What I want to help you see here is the array, the rows and columns, what we call an array, which helps us when we're trying to lead students towards the idea of grouping or unitizing or multiplicative thinking. So here I can clearly see 3 times 4 living inside of this array, or what we'd like to say is 3 groups of 4. See those 3 groups of 4 right here? But the beauty is that the commutative property, that same property we discussed back with addition, also works for multiplication, because we can also see 4 groups of 3 without even doing anything to this array. So I have 4 groups of 3 here, or 3 groups of 4. It's pretty awesome. We can also go ahead and rotate this box a little bit, and we can still see both 4 groups of 3 and 3 groups of 4. Now, there's some really interesting things about multiplication for us to explore. One area worth exploring are all of the properties and the resulting strategies that work because of those properties. For example, if we think about a common strategy that students learn during math talks at the beginning of class called doubling and halving, they learn that in these warm-ups that you can half the number of groups, and in order to remain equivalent or the same by having the number of groups, you actually have to double the quantity in that group. So look at what this looks like. It's like you're taking half of the box and you're getting rid of it, but you're actually just taking it and moving it and making this look a little bit different. So what we have here is half of 4 groups of 2 groups of 3. Now that seems pretty wordy here, but the whole intent is to try to build our mental math strategy. So let's unpack this a little bit. Let's look at the 2 groups we have. Here they are. And let's think about how many donuts are inside. We actually have 2 groups of 3 donuts inside of those 2 groups. Can you see them? Let's make it a little more explicit for you. There's your 2 groups in orange, and inside of those 2 groups, you see 2 groups of 3. Pretty cool, right? Well, if we keep going with this idea, what we can actually do is let's simplify this down, and instead of saying 2 groups of 3, let's go ahead and call that 6. So we have 2 groups of 6 here. Do you see how there's 2 groups of 6 up on the screen? Awesome. Let's try doubling and halving again. Let's have our groups again. And again, if I have my groups, that means the quantity actually halves. So if I want to maintain the same quantity or the same total, I'm going to have to double my quantity inside each group. Take a look at what that looks like. It's like we've taken half and moved it again. So we've moved it, so now it looks like horizontal. And when we look at this, we see one big group of 2 groups of 6. There is one group, and inside of that one group, we see 2 groups of 6, which is the same as us saying one group of 12. So do you see what we just did here through this doubling and halving strategy? We took 4 groups of 3 and we used the doubling and halving strategy to help us get to or arrive at the answer of 12. Now, for you and I, we're looking at this and thinking, how useful really is that? Because I know that 4 times 3 is 12. And our kids should know that too. That's completely fine, and I agree. We want students to build automaticity, but these strategies aren't for trying to find out trivial little multiplication problems. It's so that students understand how multiplication works so we can apply it to more difficult scenarios. Let's try it with 16 rows of donuts and 24 columns of donuts, or what we could call is 16 groups of 24. Now, because there's a lot of donuts there, what we tend to do instead of having students actually use tiles or counters or drawing out every individual donut, over time we try to help them see that an array is actually like a rectangle. So instead of actually drawing out 16 rows of 24 donuts, we want them to eventually visualize in their mind that we could just use a rectangle to represent those 16 rows of 24 donuts or 24 columns of 16 donuts, however you want to say it, using that commutative property. So let's go ahead and let's start applying what we know. Here, if I was to double my number of donuts, which is 24 in each group, what we can then do is we can actually have the number of rows. And by doing that, we remain at the same spot we were before. So having 16 gives us 8 rows, except now 8 rows have double the number of donuts. So before we had 16 rows of 24 donuts, now we have 8 rows of 48 donuts because of this doubling and halving. So we've taken a problem like 16 times 24, and we've essentially changed it to 8 times 48. Now you might be looking at that thinking like, I don't know how much better that is for me. For some students, they might say, well, I could figure out what 8 times 50 is, and they can go ahead and compensate later by removing 8 groups of 2 afterwards. For other students, they might say, you know what? Let's try this doubling and halving again. Let's go ahead and double my 48. And what we get is a visual that looks kind of like this. You see that we've literally doubled in the horizontal direction. And in order to compensate, we're going to have to half the number of rows, which is going to give us 4. So we actually have 4 rows of 96 donuts. Now, I don't know about you, but when I look at 4 rows of 96 donuts, I'm thinking, wait a second, that means that 16 times 24 must be pretty close to 4 times 100. It'll be a little less than 4 times 100. Actually, if I do 4 times 100, that's 400. And I know that it's actually 96, not 100. So it's 4 less. I need to remove 4 groups of 4 from 400. So remove 16 from 400. Some students might be comfortable to do that. Other students might say, you know what? I'm not really there yet. I'm not sure if I can do this in my head yet. So I'm going to try applying this doubling and halving strategy again. When I double 48, I'm going to have my number of rows to 2. So now I have essentially half of 4 rows, which is going to give me 2 rows. And when I go to double 96, that might be hard for some students. But if I really think about this and I go, wait a second, I know that I have 9 tens there. So like 96 means 9 tens and 6 ones. If I double 9 tens, I know what 9 times 2 is. So I have 18 tens. And then I have to double another 6, which is going to be 12. So I basically have 180 plus 12. Let's see what that looks like. It's like I've doubled 90 and I'm doubling 6. This is another property that we've just emerged here called distribution. This property is so important for multiplication and it's so helpful, and it actually is what our standard algorithm is built on. So let's go ahead and reduce that. We'll go ahead and say and simplify that. We have 180 plus 12, which is now 192. Some students might say, 192, pretty close to 200. So there we end up with like something close to 400 again, except I'm going to have to remove 8 groups of 2. Some kids might be okay with that. But if you're not, then we could try this one last time. Let's have a look at this. If I double or if I have 2 groups and I double the number of donuts in each group, I'm going to end up with 1 row. And when I double 192, I could literally like go ahead and do this individually. I could double 100, double 90, and double 2, right? 192 is 100 plus 90 plus 2. I could go ahead and use the distributive property here in order to get my result of 200 plus 180 plus 4. And now I have one row of 384. So regardless of how a student chooses to get there, it's totally up to them. They get to decide how are they going to approach multiplication using strategies. And we just showed you one strategy. It's unlikely that students are only going to rely on doubling and halving. This is just one of the many strategies that we try to help students build these mental math strategies through math talks at the beginning of class every day. So while that might seem like a lot of work, keeping in mind these strategies are super helpful. Like let's look at this case where we have students who have 3 boxes of donuts. You and I know that there's 3 groups of 12 here. However, for our students, what we want them to see is that over time they can build these strategies and they can actually use concrete manipulatives here in order to help them build their understanding and visualization of multiplication. At this point, we could take what we call base 10 blocks. If you look in the middle of the screen, we have base 10 blocks there where we actually have a rod that represents 10 single units. So that's one group of 10. So here we could see along the left side, we have 10 plus 2 donuts or 12 donuts times 3 donuts along the top. So we actually have a total of 36 donuts, 10, 20, 30, 32, 34, 36. And over time, we want to help students see that, you know what, we don't need the base 10 blocks anymore. We could actually draw this out using what we call an area model. And I can see here that the dimensions of the rectangles are 10 and 3 for the large rectangle and 2 and 3 for the rectangle, the smaller rectangle. 10 times 3 is 30, 2 times 3 is 6. And over time, students can build this understanding to see that, you know what, there's actually an algorithm that we can use, and it's all based off of these models that we've used. These partial products is what we call them. If I look here and I think of the standard algorithm, I can actually see like 10 times 3, which is 30. And then I could go ahead and see 2 times 3 or 3 times 2, depending how you look at it, is equal to 6. And when we add those up, we get 36. Keeping in mind, the in-between here is really what we've done is we've simply broken down the 12 into 2 parts. We call that decomposing the number into 10 plus 2. So if I multiply 3 groups of 10 plus 2, that's like 10 plus 2 plus 10 plus 2 plus 10 plus 2, or 30 plus 6. And you can see that all of these representations allow us to get to the same place. So again, this is the distributive property, which is so important to help us build our understanding of multiplication. And then as we get to larger numbers, we can apply these properties. So for example, if I have a donut box that's this big, I could start using base 10 materials and seeing that every 10 rod is equal to 10 individual donuts. I could see my 10, 20, 30, 32 donuts along the top. I can see 10, 20, 25 donuts along the side. That's the dimensions of this box. And when I multiply 10 times 10, I get 100. There's 100 donuts under that square right there. When I do another 10 times 10, another 10 times 10, I keep doing this and I end up with 600 flats, or 6 groups of 100. When I go to the far or the top right, I could see 10 times a 1, 10 times another 1. We repeat this and we see that there's a total of 40 donuts in the far upper right corner. When we look at the bottom where we see 5 donuts vertically, we can see that 10 times 5 gives us 50. We do that again and again for the other 2 10 rods. And then finally, we're left with 5 times 2 in our corner. We're left with an additional 10 donuts. Over time, students don't have to actually draw all of this out. They can actually start using their mental math skills that they've developed over time because we've been working on number fluency right from the beginning and that conceptual understanding. And what they'll start to see is that, wait a second, if I take 2 tens times 3 tens, that is equal to 6 10 times 10, or 600. So 20 times 30 is 600. We could do the same thing over here, and we see 20 times 2, which is the same as 40. In the bottom left area, we see a width of 5, or I guess a height of 5 by a width of 30. That gives us 30 times 5, 30 groups of 5, or 5 groups of 30, which gives us 150. And 5 times 2, or 2 times 5, which is 10. And when we put those together, we end up with a total of 800 donuts. But what I really want you to see is that the standard algorithm that you and I learned in school, and we really rushed towards this algorithm, it's still an algorithm that works today, and it's still something we want students to be able to use fluently. But we want them to understand where it came from. So I want to show you where this algorithm came from. If we look at our area model on the left, and we look at our symbolic or our standard notation to the right, we can focus in on 20 times 30. Notice the place value columns here. If I do 20 times 30, I end up with 600. If I go ahead and I multiply 20 by 2, we have 40. I'm doing more of a conceptual algorithm instead of carrying numbers all over the place. When I look at 5 times 30, or 30 times 5, we end up with 150. And finally, 5 times 2, or 2 times 5, which gives us a result of 10. And when we add those together, what do we get? We get the same 800 donuts in both cases. Is one better than the other? Absolutely not. But one thing that we know for certain is that if students are only using that far algorithm to the right without understanding how it works, they will have struggles along the way if they lose or forget some of the steps. So we want to make sure students have a full and complete understanding of mathematical proficiency before we rush towards algorithms. This video was intended to just scratch the surface of some of the ways we can help our students develop mental math skills for mastery with multiplication. I hope you enjoyed this video from our Fundamentals of Mathematics series. We'll see you in the next part, where we will wrap up our mental math skills for mastery portion with division. We'll see you then.